Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on exact values. What we're going to do in this video is learn how to calculate some exact values of sine, cos, and tan. You don't always get exact values. Now, if you put sine 11 into your calculator, you just get this seemingly random, irrational number. But there are some angles for which sine, cos, and tan give you exact values. So that's what we're going to look at here. So let's look at this triangle here. It's right-angled with one angle 45 degrees. So because the angles need to add up to 180, this third angle must also be 45. This is a right-angled isosceles triangle because it has two equal angles, and that means it will have two equal sides. So this side here and this side here will be equal. So I'm going to call this side here A. This side here will also be A. So using Pythagoras, the hypotenuse will be the square root of A squared plus A squared. So we can simplify this a bit. This is the square root of A squared plus A squared is 2A squared. And we can write it like this. So if I have a right-angled isosceles triangle, that means one of the angles is 45 degrees. If the two shorter sides are A, the longer side is root 2 times A. That means the hypotenuse is the square root of 2 times whatever these sides are. So if the two shorter sides were both 1, then the longer side here would be root 2 times 1, which is about 1.41. If, say, each shorter side was 8, the longer side would be 8 times root 2, which is about 11.3. So this will allow us to calculate exact values for sine, cos, and tan of 45 degrees. So if I want to calculate sine 45, I can use this angle here. I could use that one, doesn't matter. So if I use this angle here, it's opposite over hypotenuse. So it is A, which is the opposite, over root 2A. So I can get rid of these A's, cancel out. I just get 1 on root 2. Turns out that's exactly what I would get if I found cos of 45. I'd get the same thing. Cos of 45 is adjacent over hypotenuse, A over root 2A. The A's cancel. I'm left with 1 on root 2. Tan 45, on the other hand, so tan 45 is opposite over adjacent. In this triangle, if it's a right angle triangle with a 45 degree angle, the two shorter sides, the opposite and the adjacent, are the same. So tan 45 is actually 1. So there's another special triangle we can look at. It's a triangle where the angles are 30, 60, 90. So in this triangle over here, this angle would be 30. It turns out the smallest angle's always opposite the shortest side. So that angle there, 30, the other angle here would be 60. So it turns out if you have a triangle that's 30, 60, 90, then the longest side is twice as long as the shortest side. So if I call this shortest side A, then the hypotenuse will be 2 times A. So using Pythagoras, this side here would be the square root of the hypotenuse squared minus the shortest side squared. So you actually get the square root of 3A squared, or the square root of 3 times A. So if this was 1 in a 30, 60, 90 triangle, if the shorter side was 1, this side here would be root 3, this side here would be 2. If the shorter side in a 30, 60, 90 triangle was, say, 6, this one would be root 3 times 6, this one would be 2 times 6, which is 12. So again, we can use this to calculate some exact values. So let's calculate each of these exact values. So for sine 30, it would be opposite over hypotenuse. So it'd be A over 2A, which is just a half. Cos of 30 would be adjacent over hypotenuse. It'd be root 3A divided by 2A. The A's cancel out. Cos of 30 will be root 3 over 2, which is about 0.866, blah, blah, blah. Tan 30 on the other hand. So tan 30 will be opposite over adjacent. A over root 3A. The A's cancel out. You get 1 on root 3. So sine 60 is the same as cos 30. It will be opposite root 3a over hypotenuse. It'll be root 3 over 2. It turns out cos 60 is the same as sine 30. So what would be tan 60? Well, tan 60 would be root 3a divided by a. That's just root 3. So what we have here are some exact values for sine, cos, and tan, 30, 45, and 60. Unfortunately, you've just got to remember them all. But the reason I went through why this all works and drew these diagrams, if you can't remember just a bunch of numbers, make sure you can draw these diagrams. They're not too hard. If you're looking for 45, it's a right-angled isosceles triangle. If you're looking for 30 or 60, 30, 60, 90 triangle, shorter side is half the hypotenuse, and remember, shorter side is always opposite the smallest angle. So make sure you'd be able to recreate these diagrams if you can't remember all these exact values. All right, thank you so much for tuning in. This has been the luckiest maths teacher in the world. Have a great day.